Section 9.9 is on what's called the complex number system. The complex number system begins by introducing what's called the imaginary unit. The imaginary unit is a value representing negatives underneath the square root. It's something that is created to allow certain problems to be solvable, because up until this point we would say that if we had the square root of a negative number, there is no real solution, but there is an imaginary solution. So the imaginary unit is represented with a lower letter case I, and it is equal to the square root of -1. So following is if I square both sides, I get I squared equals -1. And this is what is used in what's called the complex number system. Complex numbers have the form a plus bi. This is its standard form. The a is what's called the real part, and the bi is the imaginary part. When the a equals 0, so if this first part equals 0, then there is only the imaginary part left, the bi, and that's called a pure imaginary number. If the bi part is 0, all we have is the a, which is the real number. Our first example is just simplifying radicals utilizing the imaginary unit. So we have the square root of -25. I can break that apart into the square root of -1 and the square root of 25. And I know that the square root of -1 is I, and I know the square root of 25 is 5, but writing it in our standard form, the 5 is going to come first, and then the I is going to be right after it. So we have 5i. Part B, we can split it up, and then the square root of 2, we don't know the answer to it. And then we have the square root of -1 is I. This one, I like to write it in this form with the I in front of the square root of 2. If you choose to write it this way with the I afterwards, that's fine. The only complication that sometimes arises is sloppy handwriting, where it's not clear that the square root ends after the 2. Some people will make it maybe a little extended, and then it looks like the square root is over the I. So that's why I like to write it in front of the square root, just to make it more obvious what the answer is. All right, part C, when we break it apart, not only do I pull off the -1, but then 48 is 16 times 3. This is reducing of radicals that was talked about in an earlier section. Square root of 16 is 4, and then we have the I from the -1, and then the square root of 3. The next example involves some subtracting and adding and dividing. So you're going to start out by simplifying the radical part. So the square root of -16, that's -1 and 16, which is 4i. And then we have the -12, so it's -1. 12 breaks down into 4 times 3. So we have 5 plus 2i square root 3. For the next part, the 75 is -1, 25, and 3. So we're going to have 15 minus 5i square root of 3. And then I'm also going to break it up into 2 separate fractions with 5s underneath. And this helps to be able to see more clearly exactly how this simplifies. The next task with complex numbers is adding and subtracting them. Now this is going to be pretty simple because it's just a process of combining like terms. So on letter A, between these parentheses, I have a plus sign. So I can just ignore the parentheses and combine the like terms. 2 minus 6, 3i plus 7i. Always make sure to put your answer in standard form, which means that the I term needs to be second. In part B, since it's just a plus between the parentheses, I can go ahead and ignore the parentheses. However, I do need to work with the radicals a little bit. The square root of negative 36 is 6i. And the square root of negative 49 is 7i. And then combine the like terms for your final answer. Part C has a subtraction between the parentheses, so we do need to distribute that negative sign. And then combine the like terms. And then part D, again, is subtraction, so we want to distribute the negative as well as simplifying the radicals. So it's going to be positive 2 and then positive, the square root of negative 100 is 10i. Combine like terms for our answer, and we will do more with this section in the next video.